Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve GATE 2024 problems for the discipline of Instrumentation Engineering for the subject Electric Circuits. I have taken the common topic for Electrical, Electronics and Instrumentation, so all the branch candidates can watch this video completely. Let me start solving the problems. Problem number 1. I have taken the questions from the Instrumentation Engineering discipline. So this question is taken from the topic RLC Transient. See, observe the network. The network consists of resistance, inductance and capacitance with a DC volt. So this is a RLC DC transient circuit. So first I will read out the problem. The switch in the following figure has been closed for a long time t less than 0. It is opened at t equal to 0 seconds. The value of dVc by dt. Okay. So initial condition is closed condition. The switch has been closed for a long time. At t equal to 0, the switch is going to be opened. Okay. So we need to find the rate of change of voltage across the capacitor with respect to time. So let me start solving the problem. So first I have taken the initial condition, that is switch at t equal to 0 minus. At t equal to 0 minus means which is t less than 0. So at the initial condition switch is closed. So at the closed condition circuit attains steady state condition. So at the steady state the inductor can be short circuited, capacitance can be open circuited. So at the steady state condition, inductance can be short circuited, capacitance can be open circuited to find out the current and voltage. So first I am going to short circuit the inductance and open circuit the capacitance for the given network. So in the given network, I have short circuited the inductance and open circuited the capacitance. So this part of the circuit can be discarded to find the current and voltage. So this part of the when this part is discarded, 12 volt in series with two 4 ohm resistance. Okay, this 4 ohms resistance is in series condition with another 4 ohm resistance. I am going to find the current through the inductor. Okay, current through the inductor. IL of 0 minus equal to 12 by 8. Because total voltage is by Ohm's law I have found out. 12 volt is the total voltage. Here 4 ohms and this 4 ohms are in series condition. So totally 8 ohms. So V by R 12 by 8 equal to, which is equal to 1.5 amps at the initial condition. Current through the inductor at the initial condition, that is at t equal to 0 minus. Now what they asked, dVc by dt. So with respect to voltage across the capacitors. So now let me find voltage across the capacitor at the initial condition. Okay. So here voltage across the capacitor means we can find the capacitor is connected here only. So when we want to find the voltage across the capacitor at the initial condition, that can be represented as Vc of 0 minus. By voltage division rule we can find out. Okay, what is the voltage division rule? So voltage for the respective resistor equal to total voltage into that resistance by total resistance. Okay, so by voltage division rule, now we are going to find Vc of 0 minus. So Vc of 0 minus is here we can find. Vc of 0 minus is nothing but the voltage across the resistance 4 ohms. Okay. Voltage across the capacitor is nothing but the voltage across the 4 ohms resistance. So we can use voltage division rule and we can find out the voltage across the capacitor at 0 minus. So Vc of 0 minus equal to total voltage is 12 volt into 4 is that resistance by total resistance is 4 plus 4 which is 8. 4 by 8 is 1 by 2. So 12 by 2 is 6 volt. So we got the voltage across the capacitor at the initial condition as 6 volt. Okay. So IC of 0 minus. IC of 0 minus, that is current through the capacitor. So here already we have open circuited the capacitance. So current through the capacitor is nothing but 0 amps only. This is at the initial condition when t less than 0. At t equal to 0 and 0 plus, the switch is going to be opened. Okay. So at that condition, now we need the voltage and current. Same problem only. The second condition is at t equal to 0, the switch is opened. At t equal to 0 plus switch is opened. So when switch is opened, the circuit becomes like this. So already we found the current through the inductance as 1.5 amps. So I have replaced that inductance by current, because in this problem we are going to find dVc by dt. So we can term only the voltage and current. Okay, irrespective of the components, we can represent only the current and voltage. So here current through the inductance for the 0 minus is represented as 1.5 amps. And here already we found Vc of 0 minus. Vc of 0 minus we found that as 6 volt. So I have replaced 6 volt here. Okay, so here when switch is opened, this part of the circuit can be discarded. This part of the circuit can be discarded. Okay, so when this part is not there, means 4 ohms, 1.5 amps, 1.5 amps is flowing through the capacitor. Okay, so here we can find the current and voltage. IL of 0 minus is nothing but IC of 0 plus. IL of 0 minus is nothing but 1.5 amps that we already found. That 1.5 amps is directly flowing through the capacitor. So which we can represent that as IC of 0 plus equal to 1.5 amps. So we know the current and voltage relationship. IC of 0 plus equal to C into capacitor into dVc of 0 plus by dt. Okay, capacitance into dVc by dt. So using this, we can find the rate of change of voltage across a capacitor with respect to time as dVc by dt equal to IC of 0 plus by C. So IC of 0 plus we found that is 1.5 amps. C is already, capacitance value is already given as 0.1 farad. So substituting that values, it will become 1.5 by 0.1, which is 15 volt per second. 15. Okay, so dVc by dt we found that as 15. Answer is 15. So we finished the first problem. Let me start solve the second problem. The second problem is taken from the magnetic coupled circuits. So here, first I will read out the problem. Two magnetically coupled coils, when connected in series aiding configuration, have a total inductance of 500 millihenry. When connected in series opposition configuration, the coils have a total inductance of 300 millihenry. If the self-inductance of both the coils are equal, then the coupling coefficient is dash. Okay. So let me start solving the problem. So two connections are given, series aiding and series opposition. Series aiding 500 millihenry. Total inductance is 500 millihenry. And series opposition configuration, the total inductance is 300 millihenry. We need to find the coupling coefficient. Okay. So let me write the formula first. The coefficient of coupling equal to K equal to M by mutual inductance by root of L1, L2. Okay, so here the condition given is self-inductance of both the coils are equal. So L1 equal to L2. So let me write the formulation for series aiding. L1 plus L2 plus 2M equal to given as 500 millihenry. For series opposition, L1 plus L2 minus 2M equal to 300 millihenry. So here L1 equal to L2. Both the inductances are equal. So substituting that values in first and second equation, we can find the mutual inductance. 2L plus 2M equal to 500 millihenry. 2L minus 2M equal to 300 millihenry. So therefore 2M get cancelled. When solving this first equation and second equation, this 2M get cancelled, and when we add this first equation and second equation, 2M get cancelled, and 2L plus 2L, 4L equal to 500 plus 300, 800 millihenry. Therefore L we found as 200 millihenry. Okay. So, and then by substituting that L value in any of the first or second equation, 400 2L, 2 into 200 equal to 400. 400 plus 2M equal to 500. So solving this, we got M equal to 50 Henry. So we found inductance and also mutual inductance. We can substitute that in formulation. Coefficient of coupling K equal to M by root of L1, L2. So here L1 equal to L2 is the condition. So L into L, M by L, which is equal to, I am substituting that 50 by root of 200 into 200, 50 by 200, 1 by 4. 1 by 4 is 0.25. So 0.25 is the coefficient of coupling. Okay. 0.25 is the answer. Let me start solving this third problem. See, the third problem is taken from the AC network. First, I will read out the problem. The voltage applied and the current drawn by a circuit are V of t is given, I of t is given. The average power absorbed by the circuit is dash watts. Okay. So here, before going to solve the problem, we need to know about the orthogonal signals. Orthogonal signals. Okay, orthogonal signals are the signals in which the phase difference is 90 degree. If the condition for the orthogonal signals are, if x1 of t, if any of the two signals are orthogonal signals, integral of its product will be equal to 0. So I am going to apply this condition to find out the average power for this set for this problem. Okay. So here, condition for the orthogonal signals is the product of integration of the product of two signals equal to 0 if the two signals are orthogonal signals. Okay, orthogonal signals are the signals in which phase difference is 90 degree. So here, what is the average power? Average power P average equal to 1 by T 0 to T P of T dt, where P of T is the instantaneous power. Instantaneous power is nothing but the product of V of T, I of T. Okay, so V of T and I of T is given. So when we take the sinusoidal, this total time period will become 2 pi. Okay, so this is the formulation for average power. Now I will tell you the condition for the orthogonal signals. The orthogonal signals. What about the orthogonal signals? How we can integrate the orthogonal signals? So here, now we are going to find the product of V of t and I of t. This is the total one and this is the total one. So when we multiply this, each term should be multiplied with the each of the term. So 95 into this, 95 into this, and 200 cos 120 pi t into this, and 200 cos 120 pi t into this one. And another condition, 90 cos 360 pi t minus 60 into this product and plus 90 into this one. Okay. So first I will tell you the conditions. I will list out the conditions. The first conditions are two signals with different frequency and different phase angle. With different frequency and different phase angle. Okay. Two signals with different frequency and different phase angle. Different frequency means this 120 pi and here also 120 pi. This is same frequency. Different phase angle means here 0 degree, here 60 degree. So see, this is phase difference is phase angle is different. Okay, like that. So two signals with different frequency and different phase angle or orthogonal signals. And second one, so what are the orthogonal signals? The types of two signals with different frequency and different phase angle or orthogonal signals. And sine and cosine functions with the same frequency and same phase angle. That is also said to be orthogonal signals. And product of DC component and sine or cosine functions, that is also said to be orthogonal signals. So for orthogonal signals, the product integration of the product equal to 0. So we need not find out that product. Okay, let me start solving the problem. So, listen clearly. So when we multiply this V of t and I of t to find the average power, first term 95 into 4 cos 120 pi t minus 60. 95 is the DC component. Okay. So into other other term is sine or cosine functions. So 95 into 4 cos 120 pi t minus 60 degree. That product, that integration of that product will become 0. Okay. So first term applies for the third condition. So that term can be discarded. And 95 into the second term of the current. 95 into that second term of the current, that is also said to be DC component and product of DC component and cosine functions. So that integration will also come to 0. So we can discard that also. We can remove that also. Okay. First term is over. First full function is over. Let me move to the second term. Now, this function into each of the terms in I of t. Okay. Now 200 cos 120 pi t into 4 cos 120 pi t minus 60. So 200 cos 120 pi t into 4 cos 120 pi t. So both are cosine functions. Both are having same frequency but different phase angle. Okay, different frequency and different phase angle means that is said to be orthogonal signals. Different frequency and different phase angle means that is said to be orthogonal signals. Same frequency and same phase angle means that is said to be orthogonal signals. Now, see this second term, 200 cos 120 pi t. Here 4 cos 120 pi t minus 60. Different phase angle, same frequency. So that condition is not there. So this product is not, these two signals are not orthogonal signals. That integration we need to find. So that integration we need to find. Average power P average equal to 1 by 2 pi 0 to 2 pi 200 cos 120 pi t 4 cos 120 pi t minus 60. Okay, this product will be there. That integration we need to find. So let me check for the other components. 200 into this term. 200 cos 120 pi t into 1.5 cos 240 pi t minus 75. So let me product this term 200 and this one. 200 cos 120 pi t into 1.5 cos 240 pi t means this frequency and this frequency are different. And different frequency, different phase angle. So that condition is orthogonal signal condition, first condition. Okay. So first condition is different frequency and different phase angle. So that product, integration of that product will also come to 0 only. So we can discard that also. Okay. And then next one, let me move to the third term products. Now third term into each of the current terms. 90 cos 360 pi t minus 60 into 4 cos 120 pi t. So that is also orthogonal signals. That integration also 0 only. That integration also 0 only. And then 90 into this one. 90 cos 360 pi t minus 60 degree into 1.5 cos 240 pi t minus 75. So let me product this condition. This 360 pi and 240 pi are different frequencies and here different phase angle. So that is also orthogonal signal only. Integration of that product also will be 0 only. So only the product arrives is the second term of the voltage into the first term of the current. Okay. So we can find out the average power equal to 1 by 2 pi integration of 0 to 2 pi 200 cos 120 pi t into 4 cos 120 pi t minus 60 degree. Okay. So for this product only we can find the average power, or we can integrate, or we can use this formulation average power equal to V.R.M.S. I.R.M.S. cos phi. Okay. When we find V.R.M.S, root means square value of voltage signal. This is the voltage signal and this is the current signal. 200 by root 2. See here, Vm by root 2. The maximum voltage by root 2. 200 by root 2. and IRMS is Im by root 2. So for the current, peak value is 4. 4 by root 2. What is the phase difference? Here 0 degree, here 60 degree. Phase difference is 60 degree. So cos phi is cos 60. So let me solve this. 200 into 4, 800. 800 by 2 is 400. Cos 60 is 1 by 2. So 200 watts. Okay. 200 watts. And answer is 200 watts. 200 watts. 800 by 2. Here I have mistaken. Here I have mistaken. This is 2. 800 by 2 into 1 by 2, which is 800 by 4, that is equal to 200 watts. So answer we got that as 200 watts. Okay. And the last problem. So here, like the previous problem only, this is also taken from the AC network. The current I of t drawn by a circuit is given as I of t equation is given. The root mean square value of I of t is. Okay. So here signal representation is given. From this we can find the root mean square value. Root mean square value is nothing but mag peak value by root 2. So root mean square value of the total signal is, we can find that as IRMS equal to 4 is the DC component, 4 square plus Im by root 2 for the first signal, 30 by root 2 whole square, and for the second signal 20 by root 2 the whole square, and for the third component, third function, 15 by root 2 whole square, and for the fourth function 10 by root 2 the whole square. So we can find the root mean square value by square rooting this condition. So IRMS equal to 16 plus 450 plus 200 plus 112.5 plus 50. So by adding that, IRMS equal to root of 828.5, which is equal to 28.8 amps. So we found root mean square value of the current for this signal is 28.8 amps. So thus we solved 4 problems. This problem 4 problems has taken from the Instrumentation Engineering discipline from GATE 2024 paper. This is Mani's GATE Tech Vision. This is the channel for engineering lectures. You can watch the video lectures and you can share the lectures to your friends. You can subscribe to my channel. Thank you very much for watching the video.